A supernova is the largest eruption ever observed by humans. Each detonation is an incredibly brilliant and incredibly powerful outburst of a star. One variety of supernova is caused by a dying massive star's last effort. This occurs when a star with at least 5 times the mass of the Sun explodes with a tremendous explosion. Massive stars consume vast quantities of nuclear fuel in their cores, generating enormous amounts of energy, which causes the center to become extremely heated. The pressure produced by the star's nuclear combustion prevents the star from collapsing, maintaining equilibrium between two opposing forces. Gravity attempts to compress the star into the smallest, most compact spheroid possible, while the burning of nuclear fuel in the star's interior creates a significant outward pressure that resists gravity's inward compression. However, when a massive star runs out of propellant, it cools down, resulting in a decrease in pressure. Gravity triumphs, and the star collapses abruptly. This collapse occurs so rapidly that it generates immense shock waves that cause the star's outer region to erupt. Typically, a dense nucleus and an expanding cloud of hot gas, termed a nebula, are left behind. Supernovae of stars greater than approximately 10 times the size of our Sun leave behind black holes, which are the densest objects in the universe. Now imagine being an astronomer at the start of the 17th century when the telescope had not yet been developed. With limited vision, you must explore the universe. Then one day, you see a truly spectacular scene. In the next several weeks, a new star shines brighter than Venus and remains visible throughout the daytime. As the months pass, it fades somewhat but persistently remains in the sky. Skywatchers across Europe, the Middle East, and Asia witnessed the same thing that the German astronomer Johannes Kepler did in 1604. We now know that it was a supernova explosion, a massive explosion that occurs when certain stars approach the end of their lifetimes and not a new star. The latest supernova to occur within the Milky Way was in 1604. Perhaps more nearby supernovae have occurred since then, but they have been veiled by interstellar gas and dust and have not been noticed. The Crab Nebula is an example of a remnant of a supernova that occurred thousands of years ago, with its light reaching Earth around 1054. The supernova discovered in the Large Magellanic Cloud in 1987 was the closest thing to Kepler's supernova in recent years. Additionally, several supernovae in other galaxies have been documented, although they may only be seen with a telescope. Skywatchers in Kepler's day would have missed them entirely. Therefore, it has been 418 years since we last witnessed a star explosion in our galaxy, making a close and brilliant supernova long overdue. Scientists predict that between 1 and 3 stars should burst in our galaxy per century. If the next supernova occurs, modern astronomers will be better prepared for it than Kepler was or even scientists from only a few decades ago. Astronomers now have access to telescopes that can record visible light and simulate the experience of flying near a supernova and observing it with our own eyes. Additionally, there are telescopes that are sensitive to infrared light, which can penetrate gas and dust more easily than visible light, allowing us to see objects that might otherwise be hidden. Examples of instruments that predominantly record in infrared include the James Webb Space Telescope. The electromagnetic spectrum includes both visible and infrared light, which are subatomic particles. Are they also emitted by supernovas? Modern detectors can capture them. Additionally, astronomers now have detectors that can record gravitational waves, which are tiny vibrations in the fabric of spacetime thought to be released by exploding stars. In the scientific literature, when a white dwarf star undergoes a Type 1 supernova, it sucks material off of a partner star until a runaway nuclear reaction occurs, causing the white dwarf to be blown apart and send debris hurtling into space. On the other hand, when a star runs out of nuclear fuel, it collapses under its own gravity and bounces, setting off an explosion known as a Type 2 supernova. There have been instances where both types of supernovas were brighter than their host galaxy combined. The tremendous amount of neutrinos that are released alongside the light makes Type 2 supernovas very fascinating. Neutrino emission can actually begin before the explosion happens. Even though the field of neutrino research was in its infancy when the explosion of 1987 occurred, 3 detectors were able to record a total of 24 neutrinos. It is expected that if a supernova burst within our galaxy at this time, Hundreds, if not thousands, of neutrinos would be recorded by the global network of detectors. In the event that a falling star forms a black hole, therefore preventing the explosion from producing any further stellar debris, very provocative signals might be produced. It would be awesome if you could see the black hole's sharp boundary, which indicates its formation. The missing star might then be identified by comparing it to other stars in astronomical databases. A lost star might be the site of a freshly generated black hole. The successful discovery of gravitational waves from a galactic explosion would round off the historic knowledge gained from studying gravitational wave data. Gravitational waves, which Einstein said would exist when a huge body was accelerated, are distortions in spacetime that are produced as the mass of the body accelerates. Such signals were identified for the first time in 2015. Black hole and neutron star mergers are responsible for the gravitational waves we have seen so far. Regarding the danger a close supernova may pose to life on Earth, in principle, it is possible, but the explosion would have to be quite close since there are currently no nearby stars in danger of exploding. A close supernova's radiation outburst would be disastrous. It would release harmful UV and gamma radiation into space over a period of weeks, damaging Earth's protective ozone layer. Even if they didn't reach the ground, without the ozone layer, the sun's lethal UV radiation would flood the planet, killing everything. Phytoplankton in the oceans. To humans, it's possible that something like this occurred sometime in Earth's past, around 360 million years ago, near the close of the Devonian era. A massive extinction may have been caused by a supernova. On the other hand, supernovae are not just destructive forces. They may also give rise to new life. Astronomers and physicists point out that the nuclear processes that take place deep within exploding stars and spread throughout space as a result of the blast waves they create are the source of many of the heavy elements on which humans depend. This means that a supernova would be the new gold standard for astronomers. Thanks for watching. Hope you enjoyed it. Venus is nearly identical to Earth in size, making it one of our most similar neighbors in the solar system. With a mean radius of about 3,760 miles or 6,520 kilometers, it's approximately 95% the size of Earth. Its mass is about 81.5% that of Earth. This similarity in mass and size means that Venus also has a comparable density to Earth, approximately 5.24 grams per cubic centimeter, implying a similar rock-iron composition. Venus and Earth have a comparable structure, a central iron core surrounded by a rocky mantle and a thin crust. The core of Venus, while not as well understood as that of Earth, is believed to be partially liquid, similar to Earth's. This iron core is estimated to be about 2,000 miles or 3,200 kilometers in diameter. Above the core lies Venus's mantle, composed of silicate rock that extends up to approximately 1,550 miles from the planet's center. This is overlaid by a thin crust estimated to be 6 to 12 miles thick. The rotation of Venus is a unique characteristic among the planets of our solar system. Unlike most other planets, which spin on their axis in the same direction that they orbit the Sun, Venus rotates in the opposite direction. This is a phenomenon that isn't yet fully understood by scientists, but some believe it may be due to a massive collision with a celestial body in the past, which altered the planet slowly. With a solar day, a full rotation on its axis, taking 243 Earth days, the slowest rotation of any planet in the solar system. This slow rotation contributes to the planet's lack of a significant magnetic field. Another quirk of Venus rotation is that a solar day on Venus, the time from one sunrise to the next, is shorter than its calendar day due to its retrograde rotation and orbit around the Sun. The solar day on Venus is about 16.75 Earth days. The planet's year, the time it takes to orbit the Sun, is about 225 Earth days, which is shorter than its sidereal day. This makes Venus one of the few planets where a day is longer than a year. The surface gravity on Venus is about 90% of the surface gravity on Earth. This means that if you were able to stand on Venus, you would feel slightly lighter than on Earth. However, the extreme atmospheric pressure and temperature would make it impossible for humans to survive without protection. Venus' surface appears to be geologically young, with a relatively low number of craters indicating a surface age between 300 million and 600 million years old. Scientists believe that Venus undergoes a cyclical process where heat from the planet's interior causes the surface to be repaved in a global resurfacing event. There is strong evidence of widespread volcanic activity on Venus, with thousands of volcanoes dotting its surface, ranging from less than a mile in height, diameter to over 150 mi or 240 kilometers. The planet has far more volcanoes than any other in our solar system. However, there's currently no definitive evidence that these volcanoes are still active, although recent studies suggest that some may have erupted within the last few million years. Despite the apparent geological activity, Venus doesn't experience significant tectonic activity like Earth. While Venus does have mountain ranges and rift valleys similar to those seen in tectonically active regions on Earth, it lacks the kind of large, distinct tectonic plates seen on our home planet. This might be due to the planet's slow rotation, which limits the chorus effect necessary to drive large-scale tectonic activity. Venus's atmosphere is one of its most distinctive and intriguing characteristics. The atmosphere is primarily composed of carbon dioxide, 96.55%, with most of the remainder being nitrogen. However, there are also traces of other gases such as sulfur dioxide, water vapor, carbon monoxide, argon, and helium. This composition is vastly different from Earth's nitrogen-oxygen atmosphere, making Venus air toxic to humans and most known forms of life. The atmosphere of Venus is arranged in several layers, the troposphere extending from the surface to about 40 mi up, the mesosphere stretching from the top of the troposphere to about 56 mi high, and the thermosphere, which reaches up to 125 mi above the planet's surface. Above this, there's a transitional region called the exosphere that merges with the void of space. The high concentration of carbon dioxide in Venus' atmosphere creates a strong greenhouse effect, trapping heat and making it the hottest planet in the solar system, even hotter than Mercury, which is closer to the sun. The greenhouse gases in the atmosphere absorb heat energy radiated from the sun, preventing it from escaping back into space. This results in surface temperatures averaging around 467 degrees C, which is hot enough to melt lead. There's very little temperature variation between day and night, or between the equator and the poles due to the thick atmosphere's efficient heat distribution. This results in a virtually constant furnace-like temperature all over the planet's surface. The atmospheric pressure on Venus is enormous, approximately 92 times greater than Earth's at sailing level. This is equivalent to the pressure experienced 0.62 m deep in Earth's oceans. A human exposed to such pressure without protection would be crushed. Despite this, high up in Venus' atmosphere, approximately 31 miles above the surface, the pressure and temperature conditions are similar to those on Earth's surface. Venus's atmosphere is perpetually cloaked in thick, opaque clouds that cover the entire planet. These clouds reflect about 75% of the sunlight that reaches Venus back into space, which is why Venus is so bright and easily visible from Earth. The winds in Venus's upper atmosphere are incredibly fast, reaching speeds up to 450 miles per hour, much faster than the strongest hurricane winds on Earth. These winds move in a phenomenon known as superrotation, where the atmosphere rotates much faster than the planet's surface. Near the surface, however, winds are much slower. The highest mountain in the solar system, Max Mons, rising 20 kilometers, about 12 mi above Venus's mean surface level. The planet's surface is also marked by numerous impact craters, extensive lava flows, and unique surface features like coronae, circular structures caused by the upwelling of hot material from the mantle, and arachnoids, circular structures with a complex pattern of fractures due to Venus's slow rotation and dense atmosphere. The planet doesn't experience significant seismic activity like Earth. However, recent studies suggest that Venus may still be geologically active. Venus has been a target of interest since the dawn of space exploration. The Soviet Union's Venera and Vega missions, NASA's Pioneer Venus, and the European Space Agency's Venus Express have all contributed significantly to our understanding of the planet. The Venera program achieved many firsts, including the first human-made device to enter the atmosphere of another planet and the first successful landing on another planet. These missions provided valuable data on Venus' atmosphere and surface. More recently, NASA's Mellon orbiter mapped almost the entire surface of Venus using radar to penetrate the thick cloud Cover this mission revealed details about Venus's surface features and geology. Despite the challenges posed by Venus's harsh conditions, scientists are interested in further exploring the music planet. NASA's planned Veritas and Da Vinci plus missions aim to study Venus's geologic history and atmospheric conditions, providing insights into whether Venus might have once harbored liquid water or even life. Meanwhile, the European Space Agency's Envision mission will focus on understanding why Venus and Earth took much different evolutionary music paths. Japan's Akatsuki mission is currently studying Venus's atmosphere and weather patterns. Venus, our neighboring planet, is an intriguing world of extremes. Its harsh environment poses significant challenges to exploration, yet its similarity to Earth in size and composition, along with hints of potential past water and geologic activity, keep our curiosity alive. As we prepare for new missions to Venus, we stand on the brink of major discoveries that could reshape our understanding of the solar system and our place in it. As a reflection on our own planet's potential future, Venus serves as both a warning and an opportunity for scientific music. Discovery Space has always captured humanity's collective imagination. Among the pantheon of celestial bodies that have fascinated us, Jupiter stands out as the largest planet in our solar system. Its vibrant stripes and prominent great red spot making it easily recognizable. But there's far more to Jupiter than its size and famous storm, and our knowledge has grown exponentially with advancements in space technology and exploration. Jupiter is a gas giant consisting mostly of hydrogen and helium. Its diameter is approximately 11 times that of Earth, and it's so large that over 1,300 Earths could fit inside it. Despite its size, Jupiter has the shortest day of all the planets, rotating on its axis every 9.9 hours. Jupiter's magnetic field is the strongest of any planet in the solar system, created by electrical currents driven by its fast rotation and the movement of metallic hydrogen within its outer core. Jupiter's famous bands are actually high-pressure zones characterized by lighter-colored clouds. Conversely, its darker regions are low-pressure zones. The vibrant colors we see are due to different types of clouds. Ammonia crystals create the white bands, while other chemicals produce the reddish, brownish, and yellowish hues. As for the Great Red Spot, this iconic feature is a persistent high-pressure region in the atmosphere, resulting in a storm that's been ongoing for at least 300 years. The Great Red Spot is one of the most recognizable features of Jupiter, the largest planet in our solar system. At its widest point, it stretches 1.3 times the diameter of Earth. Although its size varies over time, notably, it has been shrinking in recent decade. The storm has been continuously observed since the late 19th century, but historical records suggest its existence for at least 300 years. The Great Red Spot is located in Jupiter's southern hemisphere, nestled within a westward moving jet stream called the South Equatorial Belt. The red color of the Great Red Spot is still a subject of research. It's thought that the color red phosphorus, or possibly compounds containing sulfur, the exact chemical reactions that give the spot its vivid color, remain a mystery. The storm rotates counterclockwise with a period of about 6 days. Interestingly, the rotation speed, size, and color of the spot can change, reflecting the storm's complex interaction with its surroundings. The longevity of the Great Red Spot is intriguing. While storms on Earth last for days or weeks at most, the Great Red Spot has persisted for centuries. This longevity is likely due to Jupiter's rapid rotation and lack of a solid surface, which minimizes frictional dissipation of the storm's energy. The Great Red Spot is a window into the atmospheric dynamics of Jupiter, a gas giant with conditions vastly different from our home planet. Understanding this celestial maelstrom not only unravels the secrets of Jupiter, but also sheds light on the broader principles governing atmospheres, including our own. Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, named after Galileo Galilei, who discovered them in 1610. Each of these moons is a world unto itself. Io is the most volcanically active body in the solar system, with its surface covered in sulfur and sulfur dioxide, giving it a colorful, mottled appearance. Europa has a crust of ice, and scientists believe it might harbor a subsurface ocean, making it a potential site for extraterrestrial life. Ganymede, the largest moon in the solar system, is the only moon known to have its own magnetic field. Callisto, characterized by an extremely cratered surface, is believed to have an ocean beneath its surface as well. Jupiter was known to have 79 moons, but additional moons may have been discovered since then. Saturn isn't the only planet with a ring system. Although much fainter and smaller, Jupiter also has rings composed mainly of dust particles from impacts on the planet's small innermost moons. These rings were first discovered by NASA's Voyager 1 spacecraft in 1979. The study of Jupiter has come a long way since Galileo's first observations. Multiple missions, such as Pioneer 10 and 11, Voyager 1 and 2, Galileo, Juno, and more, have been sent to Jupiter to study its composition, magnetic field, and moons. Pioneer 10 and 11 were the first spacecraft to make a close approach to Jupiter, providing valuable data about its radiation belts, magnetic field, and some moons. Voyager 1 and 2 made significant discoveries, such as detecting Jupiter's rings and confirming Io's volcanic activity. The Galileo orbiter spent 8 years studying the planet and its moons, and the attached probe made a direct plunge into Jupiter's atmosphere, providing the first direct measurements. Its composition, the Juno mission, still ongoing as of 2021, has made significant contributions to our understanding of Jupiter's internal structure. Spare magnosphere Jupiter, the colossal gas giant, remains a focal point of curiosity for astronomers and space enthusiasts alike. Its impressive size, complex atmospheric dynamics, multitude of moons, and faint ring system make it a fascinating object of study. As we continue to explore Jupiter through telescopic observations and space missions, we unravel the secrets it holds, enriching our understanding of the cosmos. For now, we marvel at the celestial symphony Jupiter conducts, its presence a testament to the intricate, diverse, and vast nature of our solar music system. The universe is full of strange and surreal paradoxes that challenge our understanding of the world around us, from the mysteries of quantum mechanics to the mind-bending properties of black holes. The universe presents us with a plethora of phenomena that defy our intuition and challenge our perceptions of reality. This video lets you see some of the many things we do not understand in the universe, and the strange and surreal paradoxes in what we think we understand. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. Everything we know represents just 5% of the universe. What is the rest? Normal matter, protons, neutrons, and electrons make up just 5% of the universe. Staggeringly, the other 95% is something which we cannot fathom, see, or understand. We call it dark matter, which makes up 27% of the universe, and dark energy, which makes up 68%. But what are these mysterious components of our universe? Dark matter and dark energy are two mysterious concepts in astrophysics that scientists use to explain some of the strange observations that we make about the universe. Dark matter is a type of matter that does not interact with light or any other form of electromagnetic radiation. This means that we cannot directly detect it using telescopes or other instruments that rely on light. However, scientists can infer its existence on visible matter, such as stars and galaxies. Dark matter is thought to make up about 85% of the total matter in the universe, but we still do not know what it is made of. It does not behave like any of the known particles that make up ordinary matter, such as protons and electrons. Some theories propose that dark matter consists of undiscovered particles that do not interact with light or other forms of radiation, while others suggest that it may be made up of exotic objects such as black holes. Dark energy, on the other hand, is a hypothetical form of energy that is thought to permeate all of space and is responsible for the accelerating expansion of the universe. Unlike dark matter, which has a gravitational effect that slows down the expansion of the universe, dark energy has a repulsive effect that causes the expansion to speed up. The exact nature of dark energy is not well understood, but it is thought to be a property of space itself, rather than a type of matter or energy that we can directly observe. Scientists believe that dark energy makes up about 68% of the total energy in the universe. How many dimensions does the universe have? To the best of our knowledge, the universe as we know it has 3 spatial dimensions: length, width, and height, and 1 dimension of time, making a total of 4 dimensions in spacetime. This is known as the 4-dimensional spacetime. However, some theories in physics, such as string theory, propose that there may be more than 4 dimensions, possibly up to 11 dimensions, but these extra dimensions are thought to be curled up or compactified to be too small to be observed at our scale. This means that although they may exist, they are not directly observable, and their effects on the 4-dimensional spacetime can only be inferred through their influence on the physical phenomena that we can observe. These additional dimensions, would help us unify the mathematical basis of the four fundamental forces of nature: the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. Do these higher dimensions exist? And if they do, is there a way for us to measure their presence, or will we forever be trapped in our four-dimensional world? What if our universe is just one of a multitude out there? The idea that our universe is just one of many universes, known as the multiverse theory, is a popular concept in modern cosmology and physics. According to this theory, there may be many other universes existing alongside our own, each with its own unique properties and laws of physics. If this is the case, it would have profound implications for our understanding of the universe and our place in it. For example, it could help explain why our universe appears to be finely tuned to support life, known as the anthropic principle. If there are countless other universes with different physical laws and properties, it would increase the chances of at least one of them being able to support life. The multiverse theory also raises questions about the nature of reality and how we define what is real. If there are many different universes with different physical laws, are they all equally real, or is our universe the only real one? What is time? Time is one of the most difficult properties of our universe to understand. Researchers say that time is a measurable period, a continuum that lacks spatial dimensions. There seems to be an obvious direction or flow of time, and it seems we can't travel backwards in time. Why is this? Are we trapped in the arrow of time, perpetually moving forwards? Is the passing of time intertwined with the way our universe works? According to the theory of Big Bang, time itself began together with the rest of the universe about 13.8 billion years ago. Time is a fundamental concept in physics and is often defined as the progression of events from the past through the present and into the future. It is a fundamental dimension in which events occur and is often represented as a continuous line or axis. In the context of physics, time is typically measured in units, such as seconds, minutes, hours, and years. It is also an essential component of the space-time continuum, which is the four-dimensional fabric of the universe consisting of three spatial dimensions and one temporal dimension. The flow of time is often described as being unidirectional, meaning that it moves forward and cannot be reversed. This is known as the arrow of time and is often associated with the second law of thermodynamics, which states that entropy, the measure of disorder or randomness in a closed system, tends to increase over time. The nature of time is still topic of ongoing research and debate in physics and philosophy. Some theories propose that time is an emergent property that arises from the complex interactions of the universe's fundamental components, while others suggest that time is a fundamental property of the universe, akin to space and matter particles violating the laws of nature. In certain situations, two particles can seemingly be in instant connection with each other, even if they are located at opposite ends of the universe. The phenomenon is known as quantum entanglement, where two particles can become correlated in such a way that the state of one particle is instantly correlated with the state of the other, regardless of the distance between them. While this may seem like a violation of the laws of nature, it is actually consistent with the principles of quantum mechanics. However, it is important to note that this does not allow for faster-than-light communication or the violation of causality. This is because while the state of the entangled particles may be instantaneously correlated, there is no way to control or manipulate this correlation to transmit information faster than the speed of light. In fact, there is a fundamental principle in quantum mechanics known as the no-communication theorem, which states that it is impossible to use entanglement to transmit information faster than the speed of light. So while quantum entanglement may seem like a strange and mysterious phenomenon, it does not allow for the violation of the laws of nature or the principles of causality. Could this feature of quantum mechanics one day allow us to send information instantaneously over large distances? Are we alone in the universe? There are at least 2 trillion galaxies in the observable universe, with more stars and planets in them than all the grains of sand on planet Earth. So where is everyone? Why haven't we encountered life from elsewhere? Is life incredibly rare, or does it have a limited lifetime, destroying itself before it has had the chance to seek out other life forms? What does this tell us about the future of humankind? The question of whether or not we are alone in the universe is one of the most intriguing and profound questions we can ask. Given the vast size and age of the universe, it seems unlikely that Earth is the only planet with the conditions necessary for life to emerge. There are likely billions of potentially habitable planets in our galaxy alone. However, the fact that we have not yet encountered any definitive evidence of extraterrestrial life is known as the Fermi paradox. There are many potential explanations for the Fermi paradox, including the possibility that life is indeed rare, that it is difficult for life to evolve beyond a certain point, or that intelligent civilizations have a limited lifespan and self-destruct before they can explore the galaxy. It is also possible white holes, which are hypothetical objects that are the opposite of black holes. There is currently no direct evidence to suggest that they exist. White holes are hypothetical objects that are believed to exist at the other end of a hypothetical wormhole, which is a hypothetical tunnel-like connection between 2 points in spacetime. However, there is no direct evidence to suggest that wormholes exist. Either the universe is full of strange and surreal paradoxes. Our quest for understanding these is only just beginning as we continue to push the boundaries of our knowledge and explore the furthest reaches of space and time. We can be sure that the universe will continue to surprise and challenge us in new and unexpected ways, spurring us onto new and unexpected ways, spurring us onto new heights of discovery and music. Understanding our solar system is a harsh environment. Volcanoes are destructive everywhere, from the ice volcanoes of Saturn's moon Enceladus to the immense lava fields of Jupiter's moon Io to our own planet Earth. It is truly true that we would not be here if there were no volcanoes. Volcanoes influence and alter our climate. Volcanoes are both the creators and destroyers of existence. Today, spacecraft and observatories have revealed volcanoes on planets we once believed to be dead. The discovery of volcanoes on an object smaller than the moon was a major surprise. If there are volcanoes on other worlds, could there also be life? Volcanoes are among the most potent natural occurrences on Earth. They create new land, destroy the old. They emit gases that alter the atmosphere we breathe. Deep in our oceans, volcanic heat fuels bizarre new forms of life. Volcanoes help sustain life on Earth. Now we look for signs of life on other music planets. We understand that life requires water. We are aware that it requires energy. And this is where volcanoes come in, as they generate tremendous quantities of energy. If we locate volcanoes on other planets, we may discover life. The search begins with this planet, which orbits the Earth closest, Venus, a planet that closely resembles our own Venus. Venus and Earth have similar masses. Earth and Venus were very similar 3 billion years ago, with new land, new oceans, and an atmosphere. Both planets was conducive to life on Venus. However, something caused the history of Venus to diverge drastically from that of Earth. Venus took a definite turn to the dark side a long time ago. Venus is hell, our malevolent twin planet. Today, the surface of Venus is like a furnace. The surface is 900 degrees hot. It is actually heated enough to melt some metals, so you have no chance. Venus is a greenhouse world. Its atmosphere contains a high concentration of carbon dioxide. It absorbs solar heat like a blanket. Actual images of Venus' surface reveal a desolate, extremely hot desolation. The planet was annihilated by dense CO2 atmosphere. The CO2 was produced by volcanoes. Spacecraft in orbit provided the initial clues. Radar broke through Venus's thick clouds and showed volcanic formations all over the planet. These formations look a lot like the shield volcanoes on Earth. Round and flat shield volcanoes derive their name from their shape. These volcanoes ooze, but they ooze for thousands of years. Once we were able to map the entire surface of Venus using cloud-penetrating radar, we began to examine its landforms and discovered that many of them were quite familiar. In particular, we observed enormous shield volcanoes that resemble the shield volcanoes in Hawaii. The radar images of Venus were identical to those of Hawaii's shield volcanoes. In the past, Venus was home to volcanoes. We were astounded to see a picture of Venus for the first time. We discovered a cratered volcanic surface. There are at least 1,000 large volcanoes and possibly tens or hundreds of thousands of lesser ones. Lava plains cover 3/4 of Venus' surface, evidence of an ancient catastrophe. This could have been a home for life. It was instead consumed by flames. Numerous trillions of tons of carbon dioxide were expelled by Venus' volcanoes into the planet's atmosphere. The temperature rose dramatically. The oceans evaporated on Earth. Carbon dioxide is able to absorb into the rocks. It can be absorbed by the ocean. On Venus, however, there is no water, and the temperature is so high that carbon dioxide cannot even combine with the minerals. Volcanoes released carbon dioxide into the atmosphere eons ago, and as time passed, fewer and fewer methods existed to remove it from the atmosphere. Volcanoes sanitized the entire planet. If Venus ever supported life, Earth is the only known planet with life that may alter this is the gas giant Jupiter, with his moons believed to be frozen and lifeless on mystery surfaces. And lifeless as a cloud upon closer inspection on Venus, volcanoes transformed a planet similar to Earth into a hyperheated inferno. Volcanoes on a planet similar to Earth were not a surprise, but the discovery of volcanoes on the moon was an astonishment. In March 1979, the Voyager 1 spacecraft provided us with our first up-close look at Jupiter's minuscule moon Io, a world we once believed to be frozen and lifeless, and they witnessed something odd. They observed this arc next to the moon, and it almost appeared as though there was a second moon behind it. We scratched our minds and asked, what could that be? Everyone is aware that Io is lifeless, dull, and uninteresting. And then people realized, oh my God, it's a volcanic eruption. We discovered that the area is engulfed in volcanoes. It is geologically extremely active. There are constant volcanic eruptions. And what they're erupting is a great deal of sulfur, which becomes extremely heated, and sulfur changes color as its temperature changes. It may be red, orange, yellow, or even black as a result. These images of Io's visage resemble a pizza with various types of cheese and olives, where the small black spots are. Io is not dead. It is alive and growing. There are more than 400 active volcanoes. The largest pi erupts from a gigantic lava lake. It extends approximately 400 kilometers into space. It would be an extraordinary sight if we could stand on the edge of that lava lake and observe that plume shooting off into the void of space. Pale's eruptions are so massive due to Io's diminutive size that there is nothing holding the lava back, as there is virtually no atmosphere and little gravity. These enormous eruptions make Earth's volcanoes resemble fireworks. How can a moon so small be so volcanic? The answer is Jupiter. Similar to how the moon raises the tides in Earth oceans, Jupiter raises solid rock tides on Io. The orbit of Io around Jupiter is not circular. Sometimes it's closer, sometimes farther away. Jupiter exerts a gravitational force on Io. Jupiter's gravity stretches and squeezes Io. In every 2-day orbit, the ground rises and falls by nearly 300 feet. This pummeling generates extreme heat and enormous pressure wherever there are weak spots in the crust. Lava erupts. Volcanism is therefore planet scale, in contrast to Earth, where certain portions are active around the plates or in weak areas. This is an entire moon. That's one active hotspot. Io is the most volcanism active planet in the solar system. As a result of the immense power of gravity, volcanic activity on Io has taught us something new. It taught us that internal energy sources can drive volcanism in a manner distinct from that on Earth. Io is a lava world that is extremely hot and violent. It is difficult to conceive of anything surviving there. We have discovered strange eruptions on numerous planets and moons, but so far, the only world where volcanoes are linked to life is ours, or so we thought. This is Europa. It orbits Jupiter at a distance of nearly 500 million miles from the Sun and is a 2,000 meters wide sphere of ice. From afar, its surface appears to be polished up close. It's a different story. Europa is pummeled by Jupiter's immense gravity, just like its companion Io. The surface rises and bends, forming ridges and deep fissures. When we first obtained close-up images of Jupiter's moon Europa, they seemed vaguely familiar, and it turns out that they resemble Arctic ice flows. And it turns out they are the same. A global liquid ocean lies beneath Europa's several-mile thick icy crust. Magnetic measurements indicate Europa's ocean is an astounding 60 meters deep. The gravitational impact of Jupiter heating the rocky interior and melts the ice above as the core is stretched by tides and heated, possibly melting it. It is not preposterous to believe that there is a boundary between a hot core and a liquid water or ocean. Underwater eruptions on Earth are surrounded by life. The same may occur on Europa. Here the darkness is complete. The pressure crushing 2,000 Earth atmosphere is a harsh environment, but perhaps a cradle for life. If there is evidence of life on Earth, why not Europa? An energy source, volcanic activity, a universal solvent, liquid water, and a complex hydrocarbon chemistry are all present. Life would be difficult, but not impossible on Europa. There is life at every extreme on Earth. Absolute darkness. Life on Europa may resemble our own in unanticipated ways. If life exists beneath Europa's ice, it would be aquatic, but without eyes, because there is no significant light. Organisms that essentially feed off the energy of the volcano would most likely utilize sonar to make sense of their surroundings. Volcanoes on Europa could be the genesis of new life. It is even conceivable that Europa is typical, that this is the norm for planets with life. Earth may represent an exception. Consider that Europa could serve as a model for the billions of moons in the universe with liquid oceans. So all of a sudden our horizons have expanded several billion times by looking at the moons of Jupiter. Our solar system is home to more than 170 moons. Multiply this by the size of the universe, and that's a lot of potential habitats for life. Only liquid water and a source of energy are required. Potentially both are provided by volcanoes, and they're ubiquitous. This is Saturn, twice as far from the Sun as Jupiter. However, it also has volcanic moons, and similar to Europa, these moons could support life. Saturn is one of the odd planets in our solar system, with a 600,000 wide ring system, an astounding 62 moons, and one with a secret. Enceladus is one of the lesser and more distant moons of Saturn, and it's been known for a long time that it's covered in ice due to its extremely brilliant and reflective surface. However, when the Cassini spacecraft visited the planet, it made a remarkable discovery, not on the planet itself, but on Enceladus. Did the Cassini probe disclose a remarkable discovery? A massive plume backlit by the sun and erupting into space is conclusive evidence of volcanic activity. Cassini sensors zoom in on the south pole of the moon to capture these enormous craters scaring its surface. At the south pole of Enceladus, there are extraordinarily large fissures, which open and close as Enceladus orbits Saturn due to the tides. Now these fissures are enormous. They extend for hundreds of kilometers, and when they begin to open, you would see a large crass opening at approximately 100 miles per hour along its length. It be incredibly spectacular. Huge gravitational forces cause the surface to open and contract with incredible velocity. This helps produce the heat necessary to dissolve ice and form oceans beneath the surface. The conditions of the water beneath the surface of Enceladus are ideal for life. It is at the ideal temperature. It would be beneficial for life. Liquid water would be just like seawater here on Earth, and the chemistry of the water we observe erupting from these fissures suggests that it contains salt. It contains organic matter as well. Therefore, we have identified a location in the solar system where there is a strong possibility that there is life right now in the ice particles. Cassini has detected complex carbon molecules in conjunction with liquid water. They suggest that perhaps life could exist deep within this mysterious moon. Enceladus is possibly not alone. Another of Saturn's moons might also harbor life. Titan, one of the largest moons in our solar system, the only moon with a thick atmosphere, a frozen world ice as hard as rock, lakes of liquid methane. Yet we may also discover evidence of volcanoes and the tantalizing possibility of extraterrestrial life on this planet. Volcanoes are one of the most destructive forces in the universe, as evidenced by Io's raging conflagration and Triton ice and nitrogen explosions, even on Saturn's enigmatic moon. Titan, however, destruction can lead to the prospect of life. It has a diameter of 3,000 mi, making it larger than Mercury. It has the thickest atmosphere of any moon in our solar system. There is weather, including cyclones, winds, rain, and even lakes, but the temperature is so low that liquid methane replaces water. It's loaded with essential compounds for life. Titan has proven to be one of the most fascinating locations in the solar system. It's an active world. It is the only moon with a dense atmosphere, an atmosphere very similar to that of Earth due to the presence of nitrogen, and as it turns out, organic molecules. High intense atmosphere, methane gas reacts with sunlight to produce compounds essential to life. But if sunlight consistently converts methane into organic compounds, why does methane not run out? Methane is abundant in the atmosphere, but we know that it is quickly eliminated by sunlight, so it shouldn't be there. There must exist a source of methane. Something on Titan emits methane to be a crater. Infrared cameras disclose that the crater is surrounded by various types of materials. Scientists believe the green areas may be volcanic, possibly plains of lava ejected from Titan's interior. On Titan, the boiling liquid emitted by volcanoes could be either ammonia or water. Methane and ethane are emitted by Titan's volcanoes, and this is likely the cause of the planet's extremely dense cloud cover and orange atmosphere. This atmosphere likely originated from the outgassing of Titan's volcanoes. Even on a globe as frigid as Titan, volcanoes require heat. On Titan, there are two sources of heat. Radioactive substances heat the interior, and Saturn's enormous gravity caresses the moon. Similar to Enceladus, these two forces produce sufficient heat to transform ice into water and liquid methane into gas. Could volcanoes on Titan give life a chance to survive here? The chemical reactions necessary for life As we know, it requires an atmosphere of solid surface, liquid water, and heat. Volcanoes could provide everything on Titan. If life does exist on Titan, it would be truly alien. It would breathe hydrogen instead of oxygen, and possibly swim through methane reservoirs at 300 degrees below zero. There may be oceans of ethane, possibly there are tidal pools, as well as volcanic and hydrothermal activity. Perhaps volcanic heat could produce enough energy to support life on Titan. That's a speculation, but it can't be ruled out. However, we may not need to travel so far to discover signs of life. We may discover it on Mars, a volcanism-rich world much closer to home. Volcanoes are ubiquitous throughout the solar system. Planets such as Io, Titan, and Triton are intricate, volatile, and violent. Once we believed that Earth was the only planet with both volcanoes and life. Now we find volcanoes everywhere, but alien life has yet to be discovered. Volcanoes exemplify the absolute force of creation and destruction. They go hand in hand. It is literally true that if there weren't volcanoes here, we would not be here either. Volcanic cauldrons are the birthplace of life. Volcanoes create new landscapes. See the atmosphere with complex chemicals. Replace the old with the new. If volcanoes are linked to the processes of life, whereas life on other planets, perhaps the origin of the answer lies in ancient times when the solar system was immature. On a planet similar to our music, on this is the planet Mars. 3 billion years ago, volcanoes were active. The greatest volcano in the solar system still stands. The cliffs leading up to it are greater than 6 miles in height. Even Mount Everest would be comfortable in their shadow. This is the formidable Olympus Mang. It covers an area the size of Arizona. Its crater alone is 53 mi wide. A structure of this magnitude takes millions of years to construct. A period of time that volcanoes on Earth never have. The Earth's crust is constantly in motion in the depths of the Earth. A solid and the river continues to flow beneath, creating this cave, this lava conduit. Recent images imply that Mars volcanoes may have also created lava tubes. Any rocky planet with basaltic volcanism will likely contain lava pipelines. Now, after possibly millions of years of inactivity, these lava tunnels could revive life on the red planet. This existence will be our own. Radiation will be one of the obstacles that future humans will face when attempting to live on Mars, and especially during solar cyclones. The incoming cosmic rays can be lethal. The tunnels and caverns of Mars' extinct volcanoes could one day serve as an ideal home, retaining air and shielding us from harmful radiation. A long dead volcano could help fill a world with new light. Volcanoes are capable of both destruction and creation.